We are on page 267 in your Springboard book, and we are going to do these first few problems. And problem number 1 starts with a review of factoring. Remember this flow chart? If you don't remember this flow chart, be sure you get it downloaded off the Google Classroom. Because as it states right here, the question says state the common factor. State the common factor from this polynomial, and the very first question on the flowchart is, what is the greatest common factor? So that's what they're asking you to do right here, is check to see if this has the greatest common factor. Remember that this is the prime factorization of this polynomial right here. The 4 becomes 2 times 2, the x cubed becomes x times x times x, and so forth. And what we're looking for is a common factor, numbers that appear in all 3 terms. Okay, this problem has 3 terms, term 1, term 2, term 3, and it looks to me like each term has the factors 2x, okay, in them. So that means that state the common factor. 2x is the common factor. So if we take that 2x out, what's left? We have a 2, this 2 right here left, and those 2 x's, that's simplified down to x squared. And then in the next term, we factored out that 2 and that x, and that leaves that 1x right there. And then in the third term, we have minus 3. Remember, you can always check your GCF factoring by redistributing it. I sometimes say that to factor out a GCF, what you need to do is think about undistribute. What can we undistribute? Well, the 2x is what we can undistribute. If we turned around and put it back in, we should get this. So that's the way you can check it. It says then factor the polynomial. So we have this factor and this factor. We have 2 factors, but this factor right here should factor again. Now you should, if we're using the flow chart here, greatest common factor, does it have one? Yes. Factor out the GCF. Now that we factored out the GCF, how many terms are left? Well, 1, 2, 3. 3 terms are left. Is it a perfect square trinomial? No. Does the coefficient 1? No. So factor using the AC method. So here we are right here. For this factor, we're using the AC method. And remember, the AC method involves multiplying A times C together and then using this factor table. So AC is 2 times negative 3, so AC is negative 6. So we're using a factor sum table of factors of negative 6 and a sum of 1. So we see that these 2 right here are the factors that have that multiply together to give me negative 6 but add together to be 1. So when we're using the AC method, these 2 right here simply become, we take this x and we separate it into these 2 terms. It is a 1, but if we separate them like this, then we're able to have 2 groups now, and each one of those groups have a GCF. Don't forget to leave that 2x there in front. So this group right here looks like you can factor out. Okay, let's don't get this confused. I'm going to put a little bracket there. This group right here, it looks you can factor out a 2x. And if you factor out a 2x from there, it leaves you an x and a negative 1. This group right here, it looks like you can factor out a 3. And if you factor out a 3 right there, that leaves you minus 1. And now inside this, it looks like we have a GCF of x minus 1. And then that's going to leave the 2x plus 3 is my final factor. So this is just a review of factoring out a GCF and then using the AC method and the grouping. The AC method, there's several other methods you could use. Remember, you can use grouping, which is what I just did. You can use the big X. You can use slide and divide, or you can use trial and error. I used grouping, and this is just a review of factoring out a GCF and then factoring out what's left using the AC method.